Hi and Assalamualaikum. My name is Natasya Binti Hisham with metric number DN180027 and my supervisor is TS Muhammad Fahmi bin Abdul Rahman and IR TS Muhammad Karamul Zaman bin Musa as my co-supervisor. I would like to present my bachelor degree project entitled Study on the Properties of Bamboo Fibre Containing Concrete Due to Strength. I begin my presentation with the content of the slide. First, we have introduction, problem statement, objective, literature review, scope and limitation, methodology, testing, and lastly, we have references. Okay, for the introduction, durability is a requirement for the concrete buildings. In essence, the consequence of substandard environmental conditions cause crack in concrete structure, reducing their durability. Despite its widespread usage in construction, concrete poses significant risks including weak strength properties, impact resistance, and cracking. It is often assumed that as the strength of concrete develops, its ductility decreases, and so the observed opposite relationship between strength and ductility is appropriately regarded in a few structural applications. This study was conducted to investigate the workability of concrete in order to increase its strength rate. Okay, next problem statement. Plain concrete has a very low compressive strength, minimal ductility, and little crack resistance. Structural crack, which is microcrack, develop even before charge in plain concrete and comparable fragile materials, especially as a result of drying, shrinkage, or other reason for the volume change. Additionally, it is well established that temperature variation may result in stresses in concrete structure that are primarily of the same order of magnitude as the dead and live load in some circumstances. As a result, using bamboo fibre as an addition in concrete can help to overcome all of these sorts of issues while also increasing the strength of the concrete. Okay, for the objective of this study is to identify the properties of bamboo fibre, to analyze the effect of bamboo fibre as containing concrete due to compressive strength, thermal conductivity, and water absorption, and to propose the ideal concrete mixing ratio for achieving a strength almost equivalent to a normal concrete mix. Okay, next is literature review. Firstly is concrete. Concrete is one of the most commonly used building materials. Concrete is a composite material created by combining binding material. Depending on the amount employed, the mixture strength and quality will be affected. The structural design criteria are used to define the concrete construction grade. Concrete mix are divided into two categories, nominal and design. For small-scale construction and low concrete usage residential structure, nominal mixed concrete is frequently employed. Nominal mix provide a safeguard against a variety of quality control issues that frequently emerge during concrete building. Since the structural requirement may be taken into account, the appropriate concrete grade can be selected. Nominal mix for concrete grade M50, M20, and M25 are commonly used in small construction. Large construction necessitate higher strength of concrete, such as M30 and higher. Next is the type of bamboo. Bamboo is often found thriving in tropical moist forests, especially in areas near river valleys, in already logged forests, in the bush, in forest areas that have been destroyed and abandoned due to shifting cultivation activities, clearing land for agriculture, and even logging. In our country, the distribution of bamboo is usually available from sea level up to 1,000 meter high, and it can live in most areas such as on the bank of river, flat land, to the slope of hills. Areas that are not suitable for bamboo cultivation are in swampy area and submerged with water, which is muddy areas. Bamboo thrive in areas with good drainage, especially on sandy soils up to clay. In addition, acidic soils, especially those with acidity at pH 5 until 6.5, are most suitable for bamboo plants. Samantha bamboo is one of the most significant commercial bamboo species in Malaysia. This species is being taken from logging region in a random manner with no systematic management. Natural stand bamboos in Malaysia have not been properly conserved. Bamboo clumps are taken from the forest on the regular basis with no management guideline in existence. Next is application of bamboo. A variety of construction applications, particularly in developing countries, make bamboo one of the oldest and most adaptable building materials in the world. Both durable and lightweight, it is widely used in a variety of applications without further processing or polishing. Bamboo structures are simply to construct, resistant to wind and even seismic forces, and easily repaired if damaged. The construction process also incorporates associated materials such as bamboo-based panels and bamboo-reinforced concrete. Global attention has been drawn to the need for a substitute material that is renewable, beneficial for the environment, and easily accessible as a result of dwindling wood supplies and harvesting limits in many parts of the world, particularly the tropics. Because of its rapid growth, adaptability to most climatic and edaphic conditions, and superior attribute to most juvenile, fast-growing wood, bamboo appears as a very reasonable alternative. Bamboo is used in a variety of applications, including building construction, housing, bamboo furniture, plywood, which is bamboo plywood, temporary suspension bridge, scaffolding in high-rise buildings, bamboo fishing rods, blunt weapons for defense and recreation. Clumps are utilized as load-bearing component in a variety of construction projects, including roof, trusses, bridge, and monitoring towers. Because of its mechanical and physical properties, it is appropriate for use in a variety of industries, including the construction, automotive, aerospace, art and design, food and beverage, textile and garment, and pulp and paper. So this is from the previous study. For the first article titled is Experimental Investigation on Banana Fiber Reinforced Concrete with Conventional Concrete. The methodology is 6 different percentage of banana fiber, 1, 2, 3, 4, 5, and 6% having 40 mm length was used. Ordinary Portland cement of grade 53 and M30 grade concrete were used. At various periodical age, the banana fiber reinforced concrete is tested for compressive strength and split tensile strength. And the finding is, the experimental test revealed that the strength properties of concrete improved with the addition of banana fiber to the concrete. The addition of banana fiber considerably increased the strength characteristic of concrete, mainly compressive strength and tensile strength. The increase in compressive strength was up to 35.04% and 40.83% with addition of 3% banana fiber when compared with reference concrete at 28 days and 90 days. Increase of 47.39% with addition of 4% banana fiber when compared with reference concrete at 38 days for tensile strength. Next previous study is influence of bamboo fiber and limestone powder on the properties of self-compacting concrete. The methodology is the bamboo fiber as aspect ratio of 50 and a maximum length of 50 mm was varied in step of 2.05%, 0.5%, 0.75% and 1% in the SCC mix, while 10% of the limestone powder was added as a filler in each of the SCC mix. The workability of the mix was assessed by Slum Test and funnel test, while the mechanical properties were assessed by considering the compressive and split tensile strength test after 7, 14, and 28 curing age. Then the finding is was observed that SCC mix containing with the fiber content of 0.75% and 0.5% with the inclusion of 10% limestone powder achieved the highest compressive and split tensile strength value of 28.04 MPa and 3.26 MPa respectively. The results show an increment of 17.4% and 32% compared to the control mix. Hence, the bamboo fiber and limestone powder can be sustainably combine to regulate the flowability and improving the strength of the self-compacting concrete for local structural construction. For the last previous study is experimental study on concrete properties using pineapple leaf fibre. The methodology is the size cubes 150 mm times 150 mm times 150 mm, cylinder 150 mm diameter and height 300 mm and rectangular beam size of 150 mm times 150 mm times 70 mm are cast for both normal and pineapple fibre reinforced concrete at M20 grade mix of ratio 1, 1.5 and 3 is used. The water-cement ratio required for mean strength of 20 MPa is 0.45. Fibre-cement ratio of 0, 0.5, 0.10, 0.15, 0.2% were used. At various periodical age, the banana fibre reinforced concrete is tested for compressive strength, flexural test, and tensile strength. The finding is the compressive strength was increased up to 30.62% on addition of pineapple leaf fibre at 0.1%. The flexural strength was increased up to 46.858% as compared to conventional concrete. The tensile strength was increased up to 40.20% while adding pineapple leaf. Pineapple leaf fibre has hardness ranging in 60 until 70. Pineapple leaf fibre reinforced concrete increased its mechanical properties as compared to conventional concrete. Aggregate along the pineapple leaf fibre give less crushing value as compared to conventional aggregate. Okay, next is scope and limitation. To identify the proper proportion necessary to produce a quality and durable concrete utilizing bamboo. Bamboo fibre in concrete with 3 different percentages are selected to build the concrete structure, which is 1, 2, and 3%. In order to study on the performance of bamboo fibre containing concrete due to strength, there are several tests that will be studied, including water absorption, compressive strength, and thermal conductivity. However, the slum test is used to determine the fresh condition of the concrete in order to assure the batches of the same concrete are of consistent quality and strength. In this study, a total of 48 samples are required to include all testing conducted to achieve the objective of the study. Besides that, to further strengthen in achieving the objective of this study, Samantha Bamboo fibre has been selected as an additional material in concrete to be compared with conventional concrete. Okay, next is methodology. For the methodology part, the flow chart is provided to give a clear view of the journey of this study. Firstly, I would like to explain the proportion of the concrete sample that will be used for the testing. In this study, the grade of concrete used is M30 with a ratio of 1, 0.75 and 1.5, which is cement, sand, and aggregate respectively, and together with the percentage of additive, namely bamboo fibre. There will be 4 categories of sample altogether with the conventional concrete, which is the control sample. Okay, then for the detailed number of sample, the compressive strength of hardened concrete will be tested in this study after 7, 14, and 28 days of concrete maturation. Meanwhile, thermal conductivity will be measured only after 28 days of concrete maturity. Water absorption will be determined on the same sample prior to compression testing. In order to achieve the objective, total of 4 testing will be conducting. The slum test is used to determine the fresh condition of the concrete in order to assure that batches of the same concrete are of consistent quality and strength. Furthermore, water absorption tests also needed to analyze the physical properties to measure the amount of water that penetrates into concrete sample when submerged. The measured absorption of each specimen is calculated as the increase in mass resulting from immersion expressed as a percentage of the mass of the dry specimen based on British standard. The sample also tests to analyze its mechanical properties by using compressive strength test to determine whether the correct mixed proportion of various materials were used to get the desired strength, and thermal conductivity is an important factor when considering the amount of heat transfer through conduction in concrete that can lead to cracking in concrete. Okay, next is expected outcome. The expected result from the testing will be conducted is to obtain optimal values for the workability of concrete in order to increase its strength rate, so that it can be compared with the previous study whether the use of bamboo fibre is able to improve the concrete than previous studies. These are the references that involved in this presentation. That's all from me. Thank you.